Hello and welcome to another thrilling unit in geometry. This is Unit 8 and this is about geometric modeling. So what we're going to talk about mostly in this chapter is area, perimeter, volume, and all that kind of stuff. So before what I want to do in this section is talk about the area of triangles and parallelograms. Okay. So the first thing I want to do is talk about the area of a triangle and a parallelogram. So just the formulas that we need. Okay, so the first thing I've got is this. If I have a triangle, okay, you know, I'm going to just draw a couple of these like this. This is my base, okay, this is my base length. And this length here is my height, okay? The height is always going to be perpendicular to the base, okay? Let me draw a couple others that might not be as apparent. All right, this distance right here is my base. The distance from the very, very top to the bottom base, okay, the imaginary length there is my height, okay? The other one that I want to draw is this, just kind of a triangle that looks like that. And so I'm going to draw the height down like so, and that makes a right angle, and we have our height there. Okay, so our formula for the area is equal to 1/2 times the base times the height. Okay. Or we could say that area is equal to base times height all over 2. Okay, so it should be kind of a review for you. You should have already been exposed to this, but just in case you're not, there's a review. Okay, the other one that I've got is a parallelogram. Okay, so a parallelogram is this. Let me just draw kind of a generic picture of a parallelogram. All right. And so this length here, from here to here, is my base, okay? And then the distance from this point here down to the bottom, okay, that makes a right angle, is my height, okay? So the formula for a parallelogram is the area is equal to the base times height. Now this also works for a rectangle, so it works for a rectangle and a square, okay? Rectangle and square. All right, we'll look at other parallelograms later on, okay? So let's first take a look at finding the area of this triangle ABC in the coordinate plane. So sometimes they'll just give you the measurements, but a lot of times they won't. So what we have to do is be kind of savvy, and we kind of have to go through this and kind of take a look at some of these points here. Okay, so the first thing I want to do is I want to find my base. My base length is this length BC, okay? Now what I know is that this is the point 3, -8, okay? And this is the point -6, -8, all right? So the distance between 3 and -6, okay, this distance here that you can just count, and you have to kind of look at your scale, okay, to make sure you get that right, but this is going to be a length of 9, okay? Now the other thing I need to do is I need to find my height. My height is this vertical length from A to B. Okay, and I know that because it's going to form a right angle there, okay? Now this is the point -6, 6, all right, so -6, 6, and so if I just count these values, okay, from 6 down to -8, that's going to be a length of 14, okay? So now, my height is equal to 14, okay? My base length is equal to 9, okay? So now what I need to do is come over here and calculate my area. Now remember, my area is equal to 1/2 times the base times the height, okay? Some people like to do, or you can do the area is equal to base times height, all divided by 2. Okay, it doesn't really matter. Okay, now I particularly kind of like this one a little bit better, depending on the numbers that we have. But I like the fact that we're just dividing by 2. Okay, so what I'm going to do is this. I'm going to plug these numbers in. So I'm going to do 14 and 9, multiply those together. So I'm going to do area is equal to my base, which is 9, okay, and then times 14, and that's all divided by 2, okay. Now, one thing I can do is what I like about this is that it automatically allows me to kind of do some division here. So I can do 14 divided by 2 to get 7. Okay, so my next step, I could just do this division here and do 14 divided by 2, and I'm going to get 9 times 7. Okay, and 9 times 7 is just going to give me 63. So this area is 63 units squared. Okay, and we always use square units when we're talking about area. Okay, so let's go ahead down here and let's talk about this one. Now on this one, on the first one it was pretty easy because you're able to just kind of tell that you have this vertical length from A to B. But over here, you don't have that apparent length, okay? But we do know that I have a height here, okay? If you consider this the base, you know the height is always the length that is perpendicular to the base. Okay, so let's come in here. Now it asks us to use the distance formula. Now you can always use the distance formula if you want, given these points. But you know what I want to do is just use Pythagorean theorem. Okay, so it's a little bit tricky to see on this one, but I'm going to do this. I'm going to find KL, and we'll do that in red. Okay, so this length here from K to L. All right, and so what I want to do is draw in this right triangle. Now, it's a little bit harder because you're on a different, you know, you've got some different values here. But as long as we plot these points on a graph and we know where these points are, we're going to be okay. Okay. Now, what I know is that we go from -2 to 4. Okay, so this is a length right here of 6. Okay, and then going from a y value of -2 down to -5, this is a length of 3. Okay. All right, so now I know what those lengths are. Let's go ahead and do the same thing for JK. And just so you know, I'm not kidding about this. Okay, I'm serious about finding the length of JK. Okay. All right, so draw your right triangle, all right, for both of them. Okay. And so what I have here, I know that we go from -2 to 4. So this here is a length of 6, okay? And then I'm going from 10, okay, this y value of 10, all the way down to a y value of -2. Okay, so this length is going to be a length of 12. All right. So now that I have those lengths, I can come over here and I can just you know, evaluate this. So let's do KL first. All right. So KL is equal to the square root of 6 squared plus 3 squared, okay? And so then that means that KL is going to be the square root of 36 plus 9. So then KL is going to equal the, what do we have? What is it? The square root of 45? Okay, and this can be simplified into the square root of 9 times the square root of 5. All right, so then I know that KL is equal to 3 times the square root of 5, okay? And we're just going to leave it like that. All right, now the other one we need to do is we need to do JK, okay? So very similar. I just come in here. Let me kind of separate this out. All right, so we got to find the length of JK, all right? And that's going to be the square root of 6 squared plus 12 squared. All right, so then JK is going to equal the square root of 36 plus, what is that, 144? All right, so then JK is going to be, and that's going to give me 180. Okay, now evaluating this, taking out a perfect square out of 180, and the one that I found is I can take out the square root of 36. So I can do the square root of 36 times the square root of 5, okay, and this is just going to give me 6 times the square root of 5, okay? So your numbers might not always be nice and neat. They were like that kind of in middle school, but not so much, okay? So we're going to call this one our base, okay? Our base is equal to that, and we'll call this one our height, okay? So using our formula, area is equal to, base times height all divided by 2. Okay, let's plug those in. And so we're going to get 3 times the square root of 5 times 6 times the square root of 5. Okay, and this is all being divided by 2. Now the cool thing that I can do here is I can divide out, now that I have an even number, 6 over 2, okay, I can just take these two numbers and divide them out, all right? And that's going to give me 3. So I'm just going to get this. I'm going to get 3 times the square root of 5 times 3 times the square root of 5, okay? Now I can reorder this and be able to do this, on paper. We don't have to put this in the calculator because I've got 3 times the square root of 5 times the square root of 5. Okay, 3 times 3 is going to give me 9. All right, and then the square root of 5 times the square root of 5 is actually just going to give me the square root of 25, which is going to give me just 5. Okay, so you end up just getting 9 times 5. So then the area is equal to 45 units squared. Okay, and that's that. All right, so it's important that we write these down. It's important that we just show the math and show the arithmetic so, in the event that we do make a mistake, we can easily fix it. Okay. Okay, another method that we could do is called the box method, and what this allows us to do. So, kind of like the one we just had, we get some of these triangles where it's really hard to figure out what the area of them is and to find these lengths, okay? It's just kind of a pain. All right, so what I know is that what I could do is how we kind of make these triangles. What if we enclose this entire thing in a rectangle, okay? And so what we could do is we could find the area of the entire rectangle and then subtract out each of the areas of the triangles, okay? So let's write that out up here, okay? We're going to find the area of the total rectangle. So the area of rectangle minus area of the 3 triangles, okay? And that will leave us with the area that's inside, okay? So, guys, I'm giving you all these different methods on how to do it. I don't really care how you do it. I just want you to be able to do it, okay? So let's do this. Let's find the area of the rectangle, and I'm going to do that part in red, all right? And so I know that this length here goes from -4 to 2, and that's a whole length of 6, okay? And then my vertical length here, all right, is going to go from 5 down to -5. So this is a length of 10, okay? So I'm going to do, area of rectangle. Let me, kind of do that here in a second. Let me do it up here. Let me do the area, okay? And let me do this. Let me do 6 times 10, okay, because that's going to give me the area of the entire rectangle, okay? And then we're going to subtract off the individual areas of each of these triangles, okay? So let me kind of come in here and make some different colors for this length here, and that's going to be a length of 5, okay? I know that over here this is going to be a length of 1. This entire length up here is going to be 6, okay, from here to here. This is going to be a length of 2, okay? And then this, so if that's a length of 2, this one over here is going to be a length of 8. Okay? All right, so we've got those. All right, so now what I want to do is I've taken the area of the entire thing, okay, 6 times 10. All right, this length times this width. Okay, now what I want to do is go through and find each individual area of the triangles. Okay, so I'm going to do this. I'm going to do 6 times 10, the area of the whole thing, minus, and let's just start with this one. And this is base times height, so 5 times 10. And so let's do that. Let's do minus 5 times 10. Okay, and that's being divided by 2. All right, and then let's subtract off, okay, the area of this triangle here. Okay, 1 times 8 divided by 2. So minus 1 times 8, and then all divided by 2. All right, and then let's subtract off the area of this upper triangle up here, this 6 by 2 triangle. So let me subtract off 6 times 2 divided by 2. So minus then, sorry, I'm trying to get my colors right, 6 times 2, and then divide that by 2. Okay, so now let's kind of clean this up a little bit and see what we can do. You know, and a lot of it's, the hard part's just setting it up. Okay, so let's do this. Area is equal to, let's do 6 times 10. That's going to give me 60. Okay, and then let's do some division here. Okay, let's take the 10 divided by 2. So let's subtract off 5, and then times 10 divided by 2 is going to give me 5. So minus 5 times 5, and then minus 8 divided by 2 is going to give me 4. Okay, so I'm going to do minus 1 times 4. And then 2 divided by 2 is just 1, so then I'm just going to subtract off a 6 times 1. Okay, so let's kind of clean this up a little bit, and so we get area is equal to 60 minus 25 minus 4 minus 6. Okay, now minus 4 minus 6 is going to be minus 10. So I've got my area is equal to 60 minus 25 minus 10. If I'm subtracting 25 and 10, I'm really subtracting 35. So I've got 60 minus 35. And so then my area then becomes 25. Okay, so my area is 25 units squared. All right. Now, you could do, you know, you could still find something that's perpendicular and do all that kind of stuff, but that would require a lot of extra work. So, you know, this is a method, okay, and it's kind of a unique, cool method. All right, let's take a look at areas of parallelograms in the coordinate plane. And so what I want to do here is, you know, kind of think about my formula, which is area is equal to just the base times the height, okay? And let me make sure these are colored right. Base, and then times the height, okay? So I'm going to come over here, and I'm going to label my base, okay? I'm going to call this length here my base, all right? And then my height is actually going to be the distance from the very, very top, okay, all the way down to this kind of imaginary base over here. Okay, and this is going to be my height, all right, and this is going to be my base. All right, so what I know is that this point here is negative 3.5, and this point here is 0. All right, so what I want to do is realize that this is a length of 3.5, okay, and that's it. All right, and then what I've got, I know this is a y value of 3, this is a y value of negative 3, so my height is going to be a value of 6. Okay, and that's all I'm doing. Okay, just identify those lengths, we can just plug and chug. All right, so now my area, okay, is equal to 3.5 and then times 6. All right, so if I just take 3.5, multiply it by 6, it's going to give me 21. So my area of this parallelogram is 21, and that's units squared. Okay, we're dealing with square units here. Okay, and that's it. All right. Okay, now the other thing we need to do, you know, would be to find the area of this, okay, using the distance formula. Okay, and they've already kind of plugged those numbers in. They've already kind of done that for us. But let's go ahead and just draw in our triangles. Let's do it the way that I kind of taught you guys. And so let's find the distance of AB first. This will be our height. All right. And did it say, yeah, rectangle. Okay, so all I need to know in my, if I'm given a rectangle, I know that this is my height, and I know that, I'm going to make that here, and that this length here is my base. Okay. Now I know that because they're going to form a right angle because we have a rectangle. All right. So let's draw our right triangle and let's use Pythagorean theorem to figure this out. So I know that I go from a length of this length here, going from -2 to 2 to -10 is going to be a length of 12, and then this one here is going to be a length of 6. Okay, so 6 by 12. All right, and then if we do the one for the height, all right, I know that this vertical length here is going to be 4. Okay, and I know that this horizontal length here is going to be 2. Okay, so now what I want to do is use Pythagorean theorem to kind of figure that out. So for AB, let's do AB first. Okay, so for AB, I want to do the square root of 2 squared plus 4 squared. And so that's going to give me, 4 plus 16. And then AB is equal to the square root of 20. Okay, simplifying that, I can factor out a square root of 4 from that times the square root of 5. And so AB is going to equal 2 times the square root of 5. Okay, and that's that. Okay, now let's find the length of AD. Okay, so AD is going to be the square root of 6 squared plus 12 squared. Okay, and we've already done this part. Okay, we've already done this on the previous page. So, once you've already done, if you notice that, you don't need to do it twice. Okay, so 6 squared is going to give me 36, plus 12 squared is 144. If I add those together, that's going to give me square root of 180. All right, and then if I split this up, it's going to give me the square root of 36 times the square root of 5, and so that's going to give me 6 times the square root of 5. All right, and so that's that length for AB. Now, to find our area, we just want to multiply these two numbers together. So I'm going to do 2 times the square root of 5 times 6 times the square root of 5. So 6 times the square root of 5. And so now we're going to get this. We're going to get 2 times 6 times the square root of 5 times the square root of 5. All right. Square root of 5 times the square root of 5 is the square root of 25. So area is equal to 2 times 6 times the square root of 25. And so then this is just going to give me 12 times 5. So then that's going to give me an area of 60 units squared. Okay. Sorry, I went off the page a little bit. Just want to make sure you guys are able to see everything. So that's it for that page, and let's kind of move on to the next one. Okay, so continuing on with areas of parallelograms in the coordinate plane, we can also do the box method on this one, okay, where if you have an irregular shape where it's going to require you to use the distance formula to find all those different lengths, then you can take the big area, the area of this rectangle, and then subtract off the area of these triangles, okay? Now, let's go ahead real quick and let's just label the entire length from here to here as a length of 5, okay? And this one is a length of 7. And really all I'm doing is just counting, okay? So the area of my big rectangle is 5 times 7, which is 35, okay? So that's the area of the whole thing. Now we have the area of these little triangles, and I'm going to come in here real quick, and I'm just going to go in and draw in these triangles. This is a 1 by 4 triangle. And notice that I have a 1 by 4 triangle up here. Okay, a 1 by 4. Okay, now over here, I've got this length here. All right, make my triangle here. This is a 3 by 4. Okay, and this is also up here a 3 by 4. Okay, so now here's the thing. Okay, in this, they already have that. Okay, the area of triangle 1 is a 1 by 4. So 1/2 times 1 by 4 is equal to 2. And then the area of triangle 2 is 3 times 4 divided by 2, which is going to give me 6. Okay, so if we were to find the area of the parallelogram, the thing that you have to realize is that for that triangle, okay, there are 2 of them. 2 triangles, okay? Same thing down here. There are 2 triangles here. So if I were to find the area of the parallelogram, the total area, okay, I would take 35 minus the area of triangle 1 is 2, all right, but I'm going to take, I have 2 of them, so I'm going to do 2 times 2, and then minus the 2 triangles that have an area of 6, so 2 times 6. So my area here is going to give me 35 minus 4 minus 12, okay? So 35 minus 4, all right, 35 minus 4 is 31, and then minus another 12 is going to give me 19. So the area of my parallelogram is 19 units squared. Okay, so it's all a matter of, figuring out which method works for you and which one you like the best. Okay, all right, so then let's take a look at this other problem down here, and it says, the community garden has 2 flower garden plots available for the same price. Okay, the layout is displayed on a grid where each unit equals 1 meter. Okay, so each square is 1 square meter. Okay, based on only on square meters, which plot is a better purchase? So you have this option where you have a triangular piece, or you have a one of these a parallelogram garden plot. Okay, so I'm just going to go in here real quick. And what I'm going to do is calculate the area of my parallelogram. So my area of parallelogram here is just going to give me, this is a length of 2. Okay, I have a height of 3. Okay, so my area is 2 times 3, which is going to give me 6. And that's going to be 6 square meters, so meters squared. All right. Now, on this one, okay, let's use the box method on this one because it's kind of hard to determine how to calculate the area here. I don't want to use Pythagorean theorem, and I don't know if I don't think this is a right angle. Okay, so this one's pretty hard to figure out the height. So let's just do the box method. That's pretty fail-safe. Now, what I know is that this length is 3, and that this whole length is 4. Okay, and then I know that this length here is 1. Okay, this length here is 2, this length is 2, and this length is 2. Okay, so the area of the rectangle, okay, so let's do that here. The area of the rectangle is equal to 3 times 4, which is equal to 12 meters squared. Okay, now the area of the triangles are as follows. All right, so let's do this. Let's do 1 times 4 divided by 2. Okay, so I've got 1 times 4 divided by 2, which is going to give me 4 over 2, which is going to give me 2 meters squared. Okay, my next one is going to give me a 2 times 2 divided by 2. All right, so let's do 2 times 2 divided by 2, which is 4 over 2, which is 2 meters squared. Okay. And then let's do a 2 by 3 triangle. So that's 2 times 3 divided by 2. So 2 times 3 divided by 2, and that's going to give me 6 over 2, which is 3 meters squared. So now what I have is I have this. Okay, I'm going to take 12. So my total area, so my area of the triangle, okay, what I'm trying to find, area is equal to 12 minus 2 minus 2 minus 3. Okay, so I'm taking 12 minus 7, which is equal to 5. Okay, 5 meters squared. So, you have these two options where the area of the parallelogram, okay, here, this area is equal to 6 meters squared, and that the area of the triangle here is equal to 5 meters squared, okay? So this one, all right, that triangle is a better buy, okay? If they're the same price and you're getting more square feet out of this, the area is larger, then that's the one that you'd want to choose, okay? All right. So let's take a look. We've kind of talked about using the box method and using coordinate geometry to kind of do this. But if you were given something like this, okay, it says, what is the perpendicular distance between the line segments AB, okay, and CD if the area of the parallelogram is 165 square units? So let's do this real quick, okay? Let's zoom in here. We're trying to find the distance, okay, from here that's perpendicular to here. Okay, we're trying to find this height, okay? Now, what I can find here is this base length from this point over here. Okay, I could find this base length. All right, so let's do that. Let's make a right triangle, okay? And I know that my horizontal distance here, okay, from 3 to 12 is a distance of 9, okay? And I know that my the height here from 8 down to -4 is 12, okay? So I'm pretty sure that my base length here is going to be 15, but let's just double check on that. So let's find that length of CD, okay? CD is equal to the square root of 9 squared plus 12 squared. So CD is equal to the square root of 81 plus 144. Okay, and then CD is equal to the square root of, okay, what's 81 plus 144? That's going to give me 225. Okay, and the square root of 225 is going to be 15. Okay, so CD has a length of 15. All right, so this length here is 15. And that's my base length. Okay, now the reason why I did that is because my area formula is equal to base times height. Now, they gave us the area already of 165 square units. So I'm going to take that and plug it in for my area and call that 165. And that's equal to my base length, which we found to be 15 over here, okay, is equal to 15 times the height. And that's the perpendicular distance between these line segments as my height. Okay, so you don't have to do anything special as long as you know what the area is. If we didn't know what the area was, then we'd have to do other things. We could figure it out, but it'd be pretty rough. Okay, so now let's do this. Let's divide out 15. Divide 15 from both sides. So if I take 165 divided by 15, that's going to give me a height of 11. Okay, so this value here is this. Okay, and this is 11, okay, and that's what those go to, okay, these go to 11. All right, hope you guys enjoyed this video. I know it's a lot of stuff, but, you know, it's just kind of an extension of what we were doing before in the last unit. I know it's a long video, I apologize, but there's just kind of, these problems are tedious, and there's a lot to get through. So hope you enjoyed it, talk to you later, see ya, bye.